The only part of a system that we refer to as a blockchain that is actually a blockchain is the user database. All other aspects of the systems that we call blockchains, for example, the wallets, cryptocurrency, consensus algorithms, node operators, etc., none of those aspects of a blockchain system have anything to do with the technical definition of a blockchain. A blockchain is a database, or to be exact, a data structure. A database, for those who don't know, is a system used for reliably storing and accessing data over long periods of time. Most databases found on the internet nowadays are referred to by the Web3 community as centralized databases because they allow the companies, and typically small groups of leadership at these companies, full reign to edit and read whatever data they want. This includes the ability to shut down accounts, modify user data without consent, restrict user permissions, etc. Users whose data resides on centralized databases typically have little to no transparency on the data that sits inside of them. In contrast, blockchain-based databases level the power dynamic between users and operators by 1, allowing anyone who interacts with a blockchain database to read all stored data, and 2, only allowing users and operators the ability to edit data for which they hold the private keys, assuming a sufficient number of independently operated nodes on the network, of course. The mechanism for how this works is by processing at regular intervals each batch of requests that users send to a particular blockchain network. Each request or transaction sent with a valid digital signature gets stored into a data structure called a Merkle tree. A Merkle tree will store user data into leaf nodes and will build parent nodes comprised of the hashes of its immediate children, eventually resulting in a root hash code. When you take a Merkle tree storing a batch of user requests or transactions and combine it with a set of header fields containing the root hash of the current Merkle tree and the hash of the previous batch of transactions, then you now have what is called a block. And the term blockchain refers to the fact that each block is connected to the block preceding and following it via these 2 hashes in its header. Changing any user data in a blockchain would have a cascading effect that would ripple up the chain and easily allow other nodes on the network to detect that a malicious node had been tampering with data simply by reading the hashes in the header of the malicious node's last block.